Lesson 15.8 is continuity from a piecewise function. So remember that piecewise functions are written like this algebraically. It has a curly bracket and then it has some pieces and then it's restricted where the domain is. So that's what makes it start and stop and have jumps and all that stuff. So we've got to figure out, is this function going to be continuous at x equals 2? Well, at x equals 2 is where the issue is happening. And I rewrote these, I flipped them around so that I have negative 5x squared plus 13 and negative 2x minus 3. We should remember that x squared makes it a quadratic, so it's that parabola shape. This constant is its y-intercept, and so it's going through 13. A negative in front of x squared makes it flip. So I know that this function's doing this. I just don't know where it's at when x is 2. And then the other piece, this is linear, y equals mx plus b, having a y-intercept of negative 3 and then slope of negative 2. So it's going down to right 1. So I know this piece is doing this. So probably not going to be continuous here. But again, the way I would check it is just by plugging in my answers here. So we need to see when x is 2, what is the y value of this piece? So we're going to have 13 minus 5 times 2 squared. Order of operations tells me to do 2 squared first, which is 4. So it'd be 13 minus 5 times 4. Multiplication tells me 5 times 4, which is 20. 13 minus 20, that is negative 7. So actually, the piece I drew here, this is not very accurate. This should be going way down here to negative 7. And it would actually be a closed circle because this is equal to. So it is possible that they meet. Oh, I did the wrong side, that's why. So this one should have been, this I had on the left side since it's less than or equal to, but this should have been x values greater than 2. So we would actually be looking at, sorry, this is not very good, but this piece being linear going to the right. So they could meet. All right, let's try plugging into here. So it'd be negative 3 minus 2 times 2. That would be negative 3 minus 4, which is negative 7. So in fact, they do both meet up here at negative 7. So it is continuous. Okay. The other thing, if you want to get fancy about it, is saying that the limit as x approaches 2 from the left of our function is equal to the limit as x approaches 2 from the right of f of x. I'm really running out of room. But what we did was we checked the left piece, because this is x is less than, so that was coming from the left, saying it's going down here negative 7. And we checked from the right, and we said that this would also approach negative 7. The other thing that you should know is that we need to plug in actually f of 2. Well, that's going to be from the same piece because we've already plugged in 2 here, and we know that it equals negative 7. So everything checks out for our continuity definition. Let's try number 2. Is it continuous at negative 2? So again, we've got a quadratic and a linear. Do they meet the same y value? Let's check. So this would be the piece from the left. So I would plug in negative 2 for x. Negative 2 squared is 4. 4 times 4 is 16. 4 minus 16 would be negative 2. So this piece is at negative 2 is approaching negative 2, and it would be an open circle. This piece, plug in your negative 2. That'd be negative 6. Added to 6 is 0. So this piece would be approaching 0. So open circle here, closed circle here. You can see there's a jump here, so it is discontinuous. I don't even need to worry about anything else. All right, and then number 3, is it continuous at negative 4? Plug it in. That would be negative 4 squared, 16. 18 minus 16 gives me 2 from the left. This gives me negative 8 minus 3 times negative 4. That'd be plus 12. 12 minus 8 is 4. I get different values, but the other thing I want you to realize, neither one of these symbols had an equal to underneath. That means that when they're coming together here, they're both open. So let's say even they did meet. That's still discontinuous because f of negative 4 does not exist. There's no closed point there. And then the last one is tricky if you don't notice it. Determine whether this is continuous at x equals 2. Well, my breaks are happening at -2. So something's happening here, possibly, but I don't even care about that. I want to know at x is 2. Well, x is 2 when this piece, x's are greater than -2. That would be using this. And what do you know about a quadratic? You know that it's always continuous. So really, this should have been something flipped upside down. I'm trying to think how to draw this to make it make sense. I'll just keep going anyways. But let's just say it was flipped up. You know that it's continuous here at 2 because the break was only happening at -2. So if these numbers don't match, you know that it should be continuous no matter what. So check for that too.